Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing stacks topic. Following the parenthesis and scoring pattern, today we'll do the third question, which is score of parenthesis. So guys, for the first time this question might look a bit difficult if you have not solved this before, but once you understood, from the next time, trust me, you won't forget it. So let's read the problem statement. It says we'll be given a balanced parenthesis. As we have already solved the previous two questions on the same pattern, which is valid parenthesis. If you know that, then definitely you know the meaning of balanced parenthesis. Means for every opening bracket, there will be a closing bracket and at the correct location. You have to return the score of the string, and there are some formula to calculate the score. If you find any open and close bracket together, it means value will be 1. Okay, but if you will find A, B, like suppose if the bracket is open close is A. So similarly, if you will find A and then again another back bracket, then you have to do the summation of it. So correct, it will become 1 plus 1, 2. But if you will have a bracket under a bracket, then for sure you have to multiply. So following these two rules, you have to say key for the given string, what will be the calculation. So as you can see in the example number 1, you have the open bracket and for this you have the closing bracket, right? So can I say for open I have a closing, means the total score will be 1. Okay. Similarly, for open I have a close, the total score will be 1, means 1 plus 1, total 2. Correct? Now see this example. You have open, yes, but you could have given the score 1 only if you have found the closing bracket, but in this case you don't have. Okay, open, open, open. So continuously open means they will, you have to cover this in multiplication. Remember, like how this will become, this will be 1, but because it is nested, so it will become 2 into 1 means total 2. In this case, you have 3 such openings, correct? And once you found the close, so now you can say yes, for this it's 1. But as it is in nested order, means earlier also we have 2 open brackets. So now this will go in the multiplication. Okay. So basically, once you hit this first open bracket, you can say yes 1. Correct. But before that you have one more open bracket. So for sure multiplied by 2. And also before that you have one more bracket. So again multiplied by 2. So total 4. So in simple, if you have open, definitely it will be 1. If you have open inside a open, it will become 2 into 1 means 2. Again, if I'll add one more open, so you have to multiply with 2, which will become 4. Again, if you'll add one more open, so it will be 4 into 2 means 8. Okay, so this is a normal formula. So let's take another example. Suppose this. Okay, so let's say one more thing. Okay. So for this internal, you will score it 1, correct? Okay. Now for this outer one, definitely you will multiply for one more time. So it will become 2 into 1 means total 2. Okay. So means, can I say for this much part I have calculated 2. But because this is open and closed, so definitely the score will be 1. And these two are not nested, correct? So plus sign will be there, means total 3. And this 3 is inside the another bracket. So in total 3 multiplied by 2 means 6. If you got this, then you are correct. But okay, the idea is very simple. Yes, we know how to calculate, but how to write the code for it. Okay. So here in this one, once you encountered open bracket and then again you encountered closed bracket, correct? So basically from the string also, obviously there will be some calculation formula, but don't you think for any nested open, you actually look back to check how many such open brackets are there, correct? So whenever you have to look back, you always opt for stack data structure. If you are following my playlist, we know the reason, correct? Because that actually reduces our time complexity from O of n square to O of n, okay? But we can also do, like if we can do with the stack, sometimes we can even, do the space optimization on it. Means instead of putting in the stack, we increment the count also with that. But that we'll see later. In this, I'll teach you the stack approach also and the space optimization approach also. But here, how can we think by using stack? Okay, let's say we have, we took stack here, okay. First one is open bracket. So as it is a open bracket, okay, so basically we have to calculate ki whenever we are getting this closing bracket, we don't know na ki we have to give the score 1 or we have to multiply with 2. We don't know. How we can decide? With the help of open bracket. Okay, so for open bracket, the idea is very simple. If you found open bracket, just insert a 0 over there. But initially, before encountering any such brackets, initially also we can say score is 0, correct? Okay, so the idea is ki first insert the 0 in the stack and then start iterating, and once you found another open bracket, so just insert 0 again. Okay, this might look confusing, but trust me, this is the approach. Just listen for 5 more minutes and then you will understand the reason why we have inserted this 0 at first. Okay, so first we'll insert 0, and going forward, whenever we will encounter any open bracket, for that we will store a 0 over there, correct? And once we find any closing bracket, then the actual calculation will happen. Okay, and these 0 will participate in that score calculation. So now we will move to the next, which is closing bracket. Okay, so now it is a closing bracket and now we have to give it a score, correct? Okay, but closing bracket, it does not know ki it is like the score should be 1, okay, or earlier I had, you know what, earlier I had the open, like more open brackets or not, correct? Yes. So how we'll get to know? With the help of this score. Means the very first value of the stack is nothing but score till now. Okay, means before touching this close bracket, what was the score? Okay, so this 0 will say that. Okay, means if it's a multiplication, means if it is nested, then we will do 2 into this top value. Okay, then what is this previous value? Previous value says ki before this, like if it is, even if it is nested, so before this nested, what was the previous score? Okay, means it's very simple. If I encountered this closing bracket, so this 0 will tell me ki till here, what is like till index -1, what was my score? Okay, but this previous 0 will tell me before this open bracket, there might be open, close or so on. So what was their score? Because that till here needs to be added, but this score needs to be multiplied. Like, am I clear? One more example, let me teach you. Like this and this, suppose, okay? And I am saying if I am at here, correct? If I found the closing bracket. So what I am saying now, this much score, definitely this needs to be multiplied, correct? 2 into 1, correct? And this much needs to be added, correct? 1. So in the stack, like we are maintaining the stack such that 2, like you have to multiply this 2, but with what number will be present here? And the previous one before that, which needs to be added, it will be present at here. Okay, so this is how we have designed our stack. So now if you understood this much, let's start iterating. Okay, so now what I said, I am at I'm present here. So till now the score was 0, correct? Because we have open bracket. Till now we have not found anything. Okay, so the idea was what? Ki the first stack, let's save in the value, means a stack dot pop. First value will help me to get multiplied, correct? So in my score, I have to do 2 into value. Can I say yes? Can I say yes? This value, which is this, we have to multiply. Like this will be a part of multiplication. Okay, okay. Now because we have popped this, correct? Because we have popped this, so in the stack we have to push the final value. Why? Because now we'll go forward. So till here I should have calculated my answer and inserted in the stack now. So now what I'll do is in stack I will push the current score, which is a score plus, remember, previous value, which is this, correct? Yes. So what I'll do, stack dot pop. Why? Because I have to pop it now. See, because this score is now included in the score. So in total I could have, like, I can pop both of these, and in total this new score I will simply insert in my stack. But one more catch. As you can see, the value was already 0 here earlier, right? So 2 multiplied by 0, it will become 0. Then 0 plus previous 0, again it will become 0. So till now it will say 0 score, but it should have been 1, right? So hence we will do 2 into value, but we will take, if the value was 0, then definitely 2 into value will give me 0 score. So I will save the number, like I'll take the score, but max of it, okay, max of. If the value was positive, then for sure 2 multiplied by this will be my score. But if somehow the value is 0, then for a open and closing bracket, I want to give 1 score. Okay, till now if it is clear, then I'll tell you exact reason ki why only we have thought for this approach. Okay, just sit properly and try to understand this. Okay, two things are clear till now, right? Ki initially the 0 value we have inserted is actually helping me before this open bracket what was the score, because that I want to add. The topmost value is nothing but the score of this open bracket. Okay. Now, once we encounter a closing bracket, this top value will help me to get multiplied with 2. If it is 0, the score will be definitely 1. But the inner value will help me to add the previous values. So, till now, what is the score? Can I say the score will be 2 into 0, but the maximum is 1, so score will be 1. And in stack, what I have to push? So, till now, from here to here, the score is 1. And before that it was 0. So in total I will pop this, and in total I will insert 1. Correct? So I can say till now the score is 1. And definitely I'll move to the next one. Again found open bracket. So for open we always insert 0. Now again we'll move to the next, which is closing bracket. So now again for this closing, what is the topmost score? Because this needs to be multiplied with 2. Correct? But when we'll multiply, the maximum score will be 1, and anyhow this is a separate open and close bracket, right? So the score will be 1 for it. Okay, so we will pop, again the score will become 1. But now this time the previous value, that's what I meant to say. Okay, hey, from here to here the score is 1, and previously also I had score 1, which needs to be added and not multiplied. So hence in stack top value, I'll simply add the previous, the current score calculated. And in total it will become 2. So in the stack I will insert 2, and at the end, after coming outside the for loop, the stack top value will be my answer. Okay, wait, but this was very simple. Let's try to do this on some another example. Let's take another test case, a little bit messy, suppose like this. Okay, what is this? First insert 0, I told you, right? Now open bracket 0, open bracket 0, open bracket 0. As you can see, 3 open bracket, 3 zeros for it, and the very first will be, because for what is the score before this? Correct? Yes. Now what will happen? I will go on to the I'll reach to the first closing bracket. Correct? So what will be the score? It will how the score will be calculated. What is the top value? 0. Maximum of 2 into value plus 1, definitely 1. Anyhow, till here the score will be 1. Correct? So what I'll do? First I'll pop. With this it will become 1, and the previous 0 will also get popped, because remember we are popping for 2 times. 1 to calculate the value, and 1 more time to calculate the previous things. Correct? So now after popping, this score will become 1. Correct? Now it will be 0. Now again, because of this, again I'll pop this. 2 into 0, value will be 1. Previous score is 1, so 1 plus 1, 2. And anyhow, from here, see, this says score is 1, and this says score is 1. So 1 plus 1, 2. So I'll pop this 0, I'll pop this 1, and I'll insert 2. Now, the moment I encounter this closing bracket, okay, and what I told you, this value will always get multiplied, okay, and anyhow this is 2, and as it is in nested, so whatever inside this, which is 2, needs to be multiplied by 2. Correct? So again I will pop stack top value, which is 2. 2 into 2 value means 4, or 1, what is maximum? Of course 4. Okay, now what is the previous value? 0. So I will pop this also, and I'll directly insert this 4. So 2 will get popped, 0 will get popped, and 4 will get inserted. Okay, now we will move to the next. Again this one, till here what is the score? Till here what is the score? Can I say 4? Okay, now again nested. So 4 multiplied by 2, it will become 8. Correct? And what was the previous score? 0. So in total, what is the score? Of course, what? 8. Correct. So basically we will pop and directly put 8. Now we will encounter this open bracket. For this we will insert 0. Again we will we'll encounter closing bracket, and now for this, as you know, the score should be 1, and this 1 needs to be added in the 8. That's how it will happen. 2 0. So we'll pop this, and this will become 2 into 0. Definitely maximum score is 1. So this 1 needs to be added with stack top, which is 8. correct? So in total it will become 9, and we will pop this 0 and 8 and we will insert this 9. Now I hope you understood the reason why initially we inserted a 0 first, okay? Because as you can see, till now 8 was calculated, but as I found a open bracket, for that I have encountered 0. Now what we need to do with this, always this we will always aim for 2 into, like always multiply. If the value is 0, means only one such found in nested order, means it will automatically get 1 with the help of max value, correct? And whatever left over towards the left side, like whatever score we have calculated, that we will add because of this extra value 0 which we have inserted in the stack. Okay, so I hope the idea is clear. So now let's write the code for this. So first we'll make a stack of type integer, correct? Stack is equal to new stack. Done. Now in the stack, first we have to push 0 for it. I already told you the reason why we want to push. Now we have to run a for each loop to read the character from S. Char array. Now one by one we'll read ki if that character is a open bracket, then simply in the stack we have to push what? 0 for it, correct? And if not open, means for sure it's closed, and if it is closed, then we have to calculate the score. So for score calculation, first we will pop the stack top value, correct? And once done, now we have to calculate the score. So that score will be calculated with math.max. The top value means 2 multiplied by value, and if it is 0, then definitely update with 1. Now in the stack we have to push the value. What it is? Score plus stack.top, because now the second value we have to pop from the stack, correct? Once done, that we will push, and after coming outside the stack, we can simply say ki yes, return the stack.pop, like the top value, correct? That will be my final score. So now let's try to run this. Sorry, my bad. Correct. And let's try to submit this as well. So definitely the time complexity for this is O of n, because we are running just for O of n times of a single for loop, and the space wise we are using a stack, and in worst condition basically we will end up pushing n by 2 elements, because for every z, like open bracket, we are putting the closing bracket, correct? So in the worst case we'll end up pushing every open bracket, so still the size will be n by 2, which is linear only O of n. Now the thing is, can we optimize it? Means can we do the space optimization? Time wise for sure it's good, but what about space optimization? Like can we do without stack? But before that, the code which we discussed using stack, here is the code in Python and here is the code in C++ if you guys are from C++ or Python background. Okay, so now let's see the optimized code here. So the idea is very simple. In the stack, what we were doing, first we calculated the score for this, then we added, correct? And then once we popped it, whatever was the calculation 2, we multiplied 4. Then we multiplied and it will become 8, and at the end we added this, correct? Okay. So in stack, we were calculating the inner first and then we were going outside, okay? But in the space optimization one, the idea is we will calculate, and once we found this one, okay, so definitely if this was alone, the score was 1, but because this is nested, the score will become 2 into 1. Because this is nested again, so the score will become 2 into 2 into 1. So we will calculate the score for this open, like the closed bracket, then and there, means from outer to inner, you can say. Okay, so instead of putting the score into the stack which we were doing earlier, here we'll do the count and increment the counts, okay? So once I found a open bracket, so for this I will simply do a count 1. Now I will move to the next, again count 2, again count 3. So till now the count will become 3, okay? Now the moment I hit a closing bracket, correct? So I will decrement the count back to 2. Why I did this? Okay, so basically here the calculation of score idea is by using the shift operators, okay? So what do you think? For this one, what should be the score? If it is 1, definitely because of this it will become 2, and because of this it will become 4. So if I'm using a shift operator, if you don't know, if it is 1, so if I'll write 1, so I want to shift this 1 position, okay? So this is 1, this is 2. So the calculation of 1 0 Okay, this is a binary representation of number, so it will become 4, correct? So what do you think? How many times we should shift this 1 so that it will become 4? Obviously 2 times, correct? So it will become 1 0 0 and this is what, 4. Why? Because for this the score should be 4, correct? And if the count was 3, you would have done the shift operator by 3 times, correct? So that is the reason also once I found a closing bracket, I will decrease it, okay? Now this will tell me ki how many times I should shift the operator and what should be the score of that bracket. Very simple. Okay. So score will be simply score plus is equal to, we will do 1 divide like a shift operator by this count. Correct? So for this the count is 4. Now we'll move to the next one, which is again open, and again if it is open, for sure the count will again become 3, and this once we hit the close, again the count will become 2. Means for this one also the score should be 4, and anyhow it is correct because this is in the nested order 1, and definitely because of this nested and because of this nested the score should be 4, correct? Okay, we calculated, but as the earlier score was 4 and because of this again one shift by 2 times, the score will become 4 plus 4, definitely 8, and that's what we expected. So now we actually have calculated the score for this and this with the help of previous 2 open brackets. But now you will say ki still we are left with this. That's what I'm saying. We are done with the calculation, right? So now we won't do anything with for this closing bracket. But how we'll get to know ki for this we don't have to calculate? Idea is very simple. If you are present at any closing bracket and if the previous index value was open, then you have to calculate the score for that one, okay? But here we are present, but the previous one is not open bracket, means this is the nested closing brackets, and for which you already have calculated the score, right? Yes. So hence, if you are standing at any closing bracket from which the previous location is not opening, means you should not calculate for that score, okay? It might feel a bit difficult, but trust me, it's not. Like for the first time if you are hearing this, it might be, but trust me, it's very easy. Again we are here, okay, but as you can see we were here, the count was 2, correct? So you know na ki this brackets are not a part of this one, outer one, so hence the count needs to be decreased. So anyhow, as this is a closing bracket, so we'll decrease our count. Again we'll move ahead, decrease our count, it will become 0. Now we'll move ahead, as it is open bracket, increase the count, again decrease the count will be 0. In score it was 8, plus is equal to, obviously the 1 will get shifted by 0 times, means it will remain 1. So in total the score is 9, and that's what was expected, right? So without using any extra space complexity which is stack, we did this just with the help of counter and also the shift operator knowledge. Can we write the code for this? Yes. So what we need? We need a count variable definitely, and we need a score variable to calculate the score. Now we want to run the for loop for int I is equal to 0, I less than s dot length and I plus plus. So now we have to read if the current character is open or not. So if s of I is equal to a open bracket, so definitely we have to increment the count, correct? Yes. Or else if it's a closing bracket, definitely we have to decrement the count. But in the score we have to calculate how? Score plus is equal to 1 and shift operator by that many number of times count, correct? But we will do this only if the previous character, means s dot char at I minus 1 was equal to what? A open bracket, correct? Sorry, my bad, here also dot char at I. Okay, so if the previous character is open, then only we will calculate the score. So this score we will put inside the if case, and after coming outside we can simply return the score, correct? So now let's run the code, and definitely it should pass. Yes. So now let's try to submit this, and time complexity will be O of n, score will be space will be constant, right? Why? Because we are not using any extra space instead of constant, definitely for the variables. So this was a Java code, this is a Python code with the same logic, and this is your C++ code with the similar logic. And if you understood both code with stack and with the space optimization, then you are eligible to go in the sheet and mark the third question as done. And that's it, guys. It was very easy, right? Don't worry, I'll add the sheet link in the description if you guys are new to this channel. And if you really like the explanation video, please do hit the like button and subscribe the channel if not yet subscribed. And special request to all my subscribers who are solving the questions, do comment if you understood and if you solved the question. And if you guys want to connect with me on any social media, I'm available. I'm very active on Instagram and LinkedIn. You can definitely reach out to me. All the links you can get from the description. And that's it for this video. Let's meet in another video with some more interesting questions and topics. Till then, keep learning, take care of yourself and your family.